So this is just going through some notes of environmental soil chemistry. I've got an exam coming up, and this is some stuff that my assignments that I had through the week for those 12 weeks, and there's 15 questions. So just all multiple choice that we can go through. And if there's time at the end, we'll go through some slides. So something is a source of non-point pollution. So this is agricultural. EPA, the nitrate levels are at 10 milligrams and phosphates 0.05. Yep. Methanoglobia disease is an excessive of nitrogen. 2,4-D is an example of it's a herbicide, and DTT is insecticide. Effects of acid rain occur with a very acidic and high aluminium. C. Limestone and marble react with acid rain to form gypsum. Heavy metals are those elements having densities above 5 milligrams. The waterlogged situation in soil or aquatic environment will produce arsenic 3, 5, 6 or 4. It's 3. Yep. Something involves contaminated soil evacuation. It's a non-in situ. Because in situ, you're removing it, not in situ. Yep. Point out the correct statement. Well, I'm not going to read all these out. It's because they're the reverse. And volatile prepares involvement. That's right. Oh, so it's C then. In situ, something technique controls with electric current resulting in their immobilization, while V for volts vitrification. Yeah, find out the wrong statement. Biodegradation involves microbes, yes. Phyto is plants, yes. Leaching is leaching out, yes. So it's D. What are the major problems in excavation processes and soil decontamination? It's a large B. Herbicides used for herbs. Removing of poison contaminated soil aquifers is at a high temperature. The process is termed as, or high temperature, it's incinerating. And in situ, ex situ. Let's see. Oh, that's it. Next one. So it's week 2. Kyanolite, montmillerite minerals are mainly found in clay. These building blocks, different octolite, tetra will fly through these. Silicon and O is B. The coordination of the ratio is 0.4. Coordination number of aluminium is 4 to 6. Silica tetrahedral contaminates with a bond of silicon oxide it's a 1-to-1 ratio. Yep. Most stable ionic bonding of polyhedron is it's a point-to-point. Silicate structures are characterized by silicate tetrahedral. B. Most abundant mineral earth is feldspar. Find out the wrong one. Kyanolite, montmillerite. C. Decreasing order of strength of chemical bond is ionic. H bonding and van der Waals. Maximum swelling, expansion, shrinkage occurs in really good organic matter soil. So that's the montmillerite. D value of the spacing of the kyanolite is 0.7. Find out the correct statement. Vermiculite, it swells. Smegtite is a 2-to-1 and kyanolite's 1-to-1, so it's not right. Chlorite, it's chlorite. C. Iron, aluminium oxides, hydroxides are found in utasols and oxasols. B. The SI unit for specific soil is square meters per gram. Oh, next one. Fraction of humic substances which are soluble in both acid and alkali. The alkali gives it away because it's fulvic. The high soil organic matter content is usually found in the order of, this is an interesting one. So soil organic matter content is usually found in the order of, yeah, I would have thought forests, but after some knowledge, it's actually grasslands because there's heaps of nitrogen fixing bacteria going on down there, and some forests do have it, but that's the whole reason, because it's all open and it retains nitrogen a lot better. Which soils have more organic matter content? That's pretty simple. Oops. Find out which wrong combination related to activities of carbon and release of it, which pool. Well, that's not a very good one. B, one at the wrong statement. That's the wrong statement. Land uses, natural, increased soil. Land uses from natural to agricultural, increased soil organic carbon. I wouldn't think so. C. C or D? I would C. Principal chemical groups of humic colloids responsible for high negative charges are carboxylic and phenolic. One at the wrong statement. Fulvic has a lower carbon. Humic has a lower carbon than fulvic. Yes, humic has a lower carbon than fulvic. B. Yep. Soil organic matter is, well, it's negatively charged, soil organic matter, and it's got a high surface area and CC. So I'll go negative and higher A. Yep. Hymatumalic acid comes from humic. Yeah, good. CC of organic matter fraction, something increases dramatically with a something pH. So CC of organic matter increases with an increase in the pH. Yeah, because it decreases. Yeah, so increase with an increase. B. When organic function groups coordinate to metal ion and structural ring complexion is known as chelation. The 0 point of organic matter is pH. Thru. What are the soft acidic cations? Well, they're pretty soft, but they're not as soft as zinc. So zinc and copper. Because calcium, magnesium, potassium, sodium, and potassium, iron, and aluminium. Which one is in the correct order? Aluminium, aluminium to iron. No, it's iron, then aluminium, and copper. The decreasing order of metal humic substances, iron, aluminium, copper. Increase in soil organic matter content. An increase in soil organic content, something the exchangeable aluminium content in the soil. Well, it's got to go down. B is B. All right, week 4. Nearly up to CEC, fun stuff. Find out the correct statement. It's D. Find out the wrong statement. I know that's C. Some ions. By D by. Davis equations under that. 5. What will be the ionic strength of 0.05 mole per litre of sodium chloride solution? It's 0.15. When the ratio of ion activity IOP in thermodynamic solution product constant, then the solution will be saturated. B, the activity of ion, I think it's decreases, oh shit, in a matter of 1,000. Yeah. Decrease is good. As per stability diagram, something is the most stable mineral. Quartz is correct state. Yeah, these are all right. All wrong, sorry, so it's none of them. in linear, KOC and KPC. Diffused double layer of clay, the concentration of cations, they increase and the anions, the cations decrease and the anions increase. C. The electrochemical potential of the maximum of the colloidal surface drops linearly with distance from the surface. It probably is I want to say it's Langmuir. D? No, wrong. Helmholtz, double layer. Ligand exchange, the chemical absorption. The valency, this is pretty fine. So a high valency, that's the bonding power, the greater the strength, and therefore the higher the electrolytic concentration. So high, see? D, uh-oh. Which one of the following is not an assumption of Langmuir's equation? A. Oh, next one. Week 5, CC. The magnitude of the CC in soils is usually, it's greater than AEC. In addition to organic matter in soil will increase its CC over time. AEC goes down. CC is a measure of soil's capacity to bind cations and is expressed in the total amount of in a buffer method of CEC determinations measures its max. In distillation method of CEC determination, magnesia is used into the soil to evolve ammonia, D. In alkaline solution, CEC determines it's a permanent charge plus the pH. Hydrogen, aluminium are dominant in, well, they're dominant in humid regions, and CalMag are in dry, arid regions, low rainfall, B. Strength and absorption, this is the one, the strength and absorption of common cations of most colloids, this is the order, and the order is aluminium, it's full on. That goes first, and then see the next one. So if there's a calcium, see it's the answer's D. So if there's a calcium cation there and aluminium's there too, aluminium pushes, it's got a higher valency strength, so it'll push calcium out of the way. So if you've got anywhere aluminium in the soil or near your substrates and stuff like that, bang, everything else gets knocked out. It loves it. I'll show the answer. Yeah, that was a good one. The correct order of the CEC range for soil minerals is humus down, vermiculite, chlorite, colonite. Point out the correct statement. AEC, it decreases and the CEC increases with pH, so both C's, they both change, so it's D. Point out the wrong statement. More frequent liming. Soils require more frequent C. Many moles of magnesium will require for 8 molar change of sodium. Well, you've got a 2 to 8, so there's a 4 missing, B. What's the amount of gypsum? Calcium sulfate is required to replace 10 molar of sodium in the soil. 1 mole of calcium sulfate is 136. It's B. Curve, Ansel, gap on expressions are used in cation exchange to define the exchange phase. C, coexistent. It's A. Selectivity coefficient. Another one wrong. One of the correct statements. Soils with high base saturation, percentage base saturation, generally more fertile because they have a lower pH. They are more aluminium. No, it's none. D. 6. Point out the wrong statement. diffusion of sorbent. Bulk process. Find out the correct time scale for microseconds. Ion, then gas, presents a mineral. Absorption reaction occurs at A on external sites, so external is high, and interlayer is very low, so high than low, high low. It's going to be D. Natural logarithm of the reaction concentration versus time graph. Linear is negative slope, so that's a first order reaction. Something reaction is chemical when nothing happens, so that's going to be zero. Optimum line. Choose the correct statement. Order. Half-life is the first order reaction. The unit rate of constant of the first order reaction is to do with time. So it's D. The Arrhenius equation for temperature dependence rate constant on reaction rates is the coefficient. When the order of reaction is assumed incorrectly and plotting kinetic data occurs, there's going to be a curvature of the spine. Which step below is involved in the distillation of minerals? Surface chemical. D. Yeah. Which of the following is disadvantaged continuous flow? Too much corrosion. Floaters maybe disappeared. Oh, C or D. C. Yeah. A specific rate of constant for that. Half decomposition. Well, it's got to be that because it's in milliseconds. Evoch equation was originally developed to describe the kinetics of heterogeneous gases. Which one of the following is true for parabolic diffusion equation? D, it's all above, damn. The second order reaction, that's a one reaction. Right, redox. What's oxidation? What is oxidation? When you take away electrons. An oxic environment has oxic, so it's got oxygen. By reduction potential, low reduction potential. It's just A. It's D. Wrong. High reduction potential. pH is positive and high system will be pH, so it's oxidizing as. pH is range and narrow in. Reduced N model of D. Which statement is correct? P is a negative logarithm of electron activity. Yes. P is a negative logarithm of sum. Isn't A. The P range in most soils is -6 to +12. The soil system has a reduction potential of -250 millivolts to -300. The system is very reduced and water saturated as well. D. pH in the soil system is helpful to understand the wetness morphology for everything. You want to understand all that stuff. Sulfur, reducing bacteria, well, that's in an oxic environment, so that's the EH is negative. C. Soil system has more ferric than ferrous, the redox potential system will be positive. It's just above, ready to go. Magnitude of the rate of EH decreases in submerged soils depends on the everything. Which submerged soil has the Glee horizon? That would be D. B and C have it. And the oxidized layers, they're found in paddy soils. Production of magnesium oxide and nitrate are reported to occur in, that's the same, yeah, and high level D. Yes. Waterlogging helps too. This is a fascinating question. Did you know waterlogging helps to fix soils totally? So you can put it in see this question, the answer is D. It can actually reduce the pH of alkaline. It can increase the acidity and bring both of them. It can neutralize it. It's fascinating. The answer is D. That's a really good, I was amazed at that. That really works really, really well. All right, week 8. What about the incorrect statement? Soil pollutants have chemical nature. Soil pollutants cannot change. Yes, they can. B. Which form of nitrogen is less mobile in soil? Nitrate, ammonium, nitrite, no, not nitrogen, or nitrogen oxide. It's that one, B. Which type cannot store high concentrations of nitrogen? The cooler climates can't store it. B. Nitrification means fixation of nitrogen. High phosphorus concentrations can be found in soil with high amounts of organic matter. Which statement's correct? The amount of water soluble P is low, P is immobile, P is mobile, A and B. P is immobile, it's D. P can be fixed in acid soils mainly by aluminium iron oxides. C, yep. pH range of the highest availability of phosphorus. You should all know this one. If the lake is categorized obliterotropic, means no or nutrients. Aging at lake system goes from poor nutrients to heaps of nutrients. A eutrophication is increasing water levels, reducing DO, increasing, no, D, Salt is produced in the reaction of acid and base. The source of the cation in the salt is acid. It's base. Fuck, I've got another one wrong. In solar systems, the distribution of ions in between solid and liquid phase depends on what's the exchange capacity. Which ions are considered as potent pollutants in saline soil? Saline, it's sodic. Metal sulfides, what's that? Iron sulfide and zinc sulfide are mostly found in shit. Zinc's positive. A and C, I reckon it might be D. It can't be anaerobic. Sulfide. Ah, hang on, there you go. That's the answer. Sulfide's B. Huh. Well, running out. 10 minutes left. Shit, will we get through it? Week 9, concentration pollutants in soil, liquid phase is governed by concentration pollutants is governed by, it's the reduction group, it's the D, it's all of them. Damn it. KO, the Ka means, that's the acidity constant. C, yeah. Concentration, the brackets around the bases mean there. T, D. In aqueous solutions, H2O is considered as a rad present, except B. Choose the right equation. There's none because there's a negative in there. pKa terms means it's to do with the acid strength. Lower pKa means density. Strong acid falls like density. Yep. Chemical shows its tendency to precipitate. That means it's saturated with the other chemical. Saturated with the same chemical. Chemical shows a tendency to dissolve. That means it's saturated with water. IPK means that's a saturated mix. Stability of crystalline form of chemicals depends on all of them. Which form of chemicals substance is more stable? Meta. Surfactants, well, they disappear, don't they? Disperse. The role of surfactants is to soluble. The equation KW is that's O and W, so it's organic water. Quick, let's go. 10, the wrong statement. Temperature, let's just see. On the picture, adsorption, D, that's adsorbate and adsorbent. It's hysteresis. I'll fly through if I know. Absorption of pollutants in the soil surface is a chemical bond. Electrically neutrally on the closed surface requires something else. Electrically neutral. It's neutral, it's equal. Diffuse double layer. CC helps. What are the things that can be absorbed at CC? D. That's a good question, that. It's interesting to go into that, how they produce large complexes of bacterial cells behave as, it's either or, C, but they mostly perform as an anion. And mostly negatively charged bacterial cells mostly carry negative charge as bacterial get absorbed on negative charged surfaces. They get pulled in by resin. D and C. What's a negative? That's when it's repelled. C. Negative adsorption. B. Greater. What are the factors that affect negative absorption? It's all of them. Negative absorption decreases when soil pH increases. The absorption of non-ionic components of soils. CC doesn't it? Carbamates and urea are considered as, they're pollutants. Non-ionic as well. D. We get it done. Try 5 minutes left. Models are used for, I'm going to find out everything. No, they're not. They're used to predict stuff. Just predict. How many types of models are there? There's 4. Which model gives you the complex phenomena? Research. Models set out parameters. It's a stoichiometric. Dealing with soil, different 3 points are phenomena. It's A. Modelling of fate soil pollutants is 2 phenomena. It's a source sink and coupled. D. How many pesticide molecules move through the soil profile? Pesticides coming through the soil profile. A. Combined by B, so it's D. The convection dispersion model. Convection dispersion has 3 steps. Concentration gradient. Space convection theories, dispersion of porous materials calculated from time. aerospace and chemical engineering are used in metal. The models that are used for compartment description in calculating water flow and capacity. See how much it is. And this is a negative, so it's none. Bell reach is basically, it's a leaching model. Last. Week 12 of this week 12 course. Why soil analysis is important. It's for all of that stuff. Choice of soil analytical techniques depends on, well, it's definitely cost and calibration. D. What's the name of the instrument which is used in analysing pollutant materials? It's an ICP AES. Soil samples should be stored between 0 and 4, and the samples should be allowed to dry in air above 40 Celsius. Otherwise, the N and the P will be sensitive to that and not give you a correct reading. Lyophilization is to do with the drying and the cryodesiccation. D. Under 2 mil for crushing when you measure it when you're testing. Plastic sieves are better than metals. The metals, bloody plastic contaminations can be avoided by using plastic sieves. Yep, A. Some solution is better for extracting nitrate and not ammonium. It's 2 milligrams of calcium chloride, potassium chloride. Continuous flow analyzer is used to analyze, oh shit, it's inorganic. Continuous flow, B. Good. Dumas method. B. Yes. In CHNS analyzers, SO, CO, and OH2 are detected by thermal to heat job. Why is a P extracting solution? It's all of them. You can use all of them. It's amazing that. IES, it's a spectro. We did it, guys. 2 minutes to go. Amazing. This is the, if you wanted to know the information too, this is the lectures. I've got it on my website. Here, all of the classes. So it goes from up here to lecture 1, right down to lecture 60. And I've got the live one here in the middle here where I've asked him some questions. It was funny. Here we were talking about it. He was saying stuff, so it's interesting. And yeah, if you guys want to learn any more, please hit me up. I'll be more than willing to help out and go through this stuff because it's fun. It's interesting. What's some other slides? I've got 60 seconds. You're welcome to ask anything if you want. Big 7, so that's all the different stuff. I don't know what the slides are offhand. All right, well, it's less than 1 minute. We've made it through it all. So this is I hope you enjoyed environmental soil chemistry. It was a 2020 course through this university in India, and it was enjoyable. Hope you all had fun. I'm going to stop the recording now because we're going to go soon. See you all. Hope you had fun. See you guys. See you next time. Bye-bye. Recording.